Hello and welcome to Apropos, a conversation between Clojure programmers that you can join in on live on YouTube. We're going to discuss a few Clojure news items and share our opinions on them. Then we're going to jump in the REPL and code some exercises or do some demos. If you're joining us live, feel free to comment in the chat and we'll try to address the questions. With me today, we have Mia. Hello.
Hi.
Mike. Hello, Mike. And me, I'm Eric.
Hello.
Mike.
Hello.
Hello, Mike.
Hello. Can you hear me?
And me, I'm Eric. I hear you.
Hello. All right. Hello.
So we have some nice topics for today. Ray isn't going to be joining us, so it's just the three of us.
He's on vacation. He's alive. He's fine. We are not holding him in a basement somewhere. He's being held in a very pleasant basement in England, I believe.
Yeah, I don't I don't know if that was clear that we did not kidnap him and send him on vacation.
Yes, Ray will not be joining us today.
Yeah, he's having fun. So are we.
Never.
Indeed.
All right. So the first bit of news is you are watching this on YouTube because the podcast is now defunct. We didn't get enough listeners. We did a very informal poll, and it turned out that most people did not care about the podcast. It was a little bit of extra work for us and a lot of work for the editor. And so if you're into watching it on YouTube, well, no, nothing will change for you. But if you, well, see, that's
You
the
have to
thing.
go on a jog and listen.
Yeah, you got to find some other way to listen to this on
Should
YouTube.
we let them sign a petition if they want the podcast back?
No, I think what we should do is say if you want the podcast, you can somehow convert the YouTube video into audio and host it yourself. And if you do that and you have a system set up that other people can use, we'll share it.
Or just like play it on YouTube and listen to it, right? That's a thing. That's a thing. That's what I do with all the weird shit my dad sends me. Yeah.
I do that too. Especially someone who doesn't use a lot of slides in their presentations.
Mm-hmm.
I listen to that. Right, but now it's not going to be as confusing. You're on YouTube, and if you're not, then you know. So there you go. All right. Still, tell your friends. We're very happy that you're here. I don't know how many subscribers we have now, but it is it was over 500 last time, right? Pretty cool.
I think you're right. Yeah.
And
oh God, no, there's a lot more than that. Jeez, this is what happens when you take a break. 579.
Oh wow, that's a big, yeah. So it's been what, 4 weeks since we've done this. So people missed us. There you go. Let's keep doing it. All right, next news item. Confluent, who is Kafka, basically the company that does Kafka, they bought Distributed Masonry, which is the people who make Onyx. Onyx is a Clojure system, and I guess there was some kind of merger, acquisition, hostile takeover. Does anyone know anything about this?
Well, we know that at least the people involved are Michael Drogalis and Lucas Bradstreet. But in terms of the details of that acquisition, no. I know nothing.
Okay.
I know they're in Seattle too, so that's.
Well, y'all keep talking because I'm gonna try to read an article real quick about this.
Yeah, I'm curious. There actually wasn't a lot of gossip about it on our Slack, which surprises me because we use Confluent.
Oh.
So it looks like they're going to be using the Onyx platform on their cloud storage and processing, Confluent Cloud. Which
is really nice looking. I went to the Google Cloud conference. I got a free ticket. It's a sustained ad. It was a lot of money for a sustained ad, but food was great. I had a lot of fun. But I went to the Confluent Cloud talk, and the cloud tools are gorgeous.
Cool.
I can understand why they're investing some time in this.
So what is Confluent in general? I've never even heard of that.
So Kafka is, you know Kafka, the tools, it's this open source. So Confluent is a team that builds tools for Kafka and manages those tools. So we use Confluent tools for our Kafka service.
Looks like Mia just froze again.
For a service for Kafka in particular. They have a few things that they make that are really nice. One of the big ones, which we don't use, is KSQL.
So it seems like Onyx's stuff kind of fits in with what they do then, at least in terms of streaming processing. And
yeah, I can understand why. They seem to be focusing on their cloud stuff more and more, and I can understand why they would want Onyx for that.
And I wonder if Drogalis is sticking with them or if he's going to go off and do something new. It's kind of... He has that option, I guess, at some point.
He has a nice Twitter thread, which I wish we could really link to something in the chat. But if you search for Confluent and Onyx, it comes up. So, I mean, it just is talking about how happy he is to have sold it, and he thinks this is the right next move. It wasn't out of desperation or something, is what he's implying.
That's great. Yeah.
Yeah. That Kafka was already dominating so much in the streaming space, and so they were gonna they were moving that way anyway to be, I don't know how Kafka works, so I don't know if it's a Kafka consumer or something like that, to be on the end of a Kafka stream.
Yeah.
I mean, how often do you have people in the Clojure community starting companies and then having them sold? And that's awesome. Yeah.
The last one I remember was Twitter bought Storm.
Okay.
Is that right?
Well, then Staples bought Runa, which didn't end well.
Staples bought Runa, and then it became Staples Labs, right? And then they closed it. Is that true?
There's some gossip.
Okay. But is it still around? Is Staples Labs still around?
That I don't know.
Do they still do Clojure?
I know that they were kind of phasing it out, so I don't know what finally happened with it.
And then Walmart Labs was originally a Clojure company that they bought.
And then did Monsanto buy Climate Corp?
That's right. So it seems like there's a good percentage of Clojure companies that get bought, if you can name so many.
Well, or we can just name them all. I mean, which would imply that there's not that many.
No, but percentage-wise, because how many Clojure companies in general are there? You probably don't even hear about them until they're bought.
That's true. Yeah.
So I never used Onyx. I never had a use for it. At least I don't think I did. And whenever I would try to learn about it, it was just stuff that I had no idea. It was a lot of terms that I didn't understand. So I didn't even know if it was something I would ever need to use. So I never even wound up looking at it, really. I just didn't understand it, to be honest. So do either of you know what Onyx was?
I know that we chatted with the PyroStore people quite a bit, trying to figure out storage solutions, long-term storage solutions for our Kafka stuff that we're using. but I don't know what came out of that. Reed would actually know. He was the one who talked to them.
Okay.
But I'm not that familiar with Onyx in particular.
I mean, it's a stream processing engine. You know, if you want to summarize
what does that mean? What does that mean?
So like, let's say you have like instead of let's say you like have a bunch of events that you need to process, right? That are just coming in incessantly, and for each one you need to maybe map a function over it or something like that, or maybe join it up with another stream,
and it's so many that you need to distribute it.
And have it
running on a bunch of things. I see.
Yeah. So right now we're using Kafka Streams for this, which is a Confluent tool. So Kafka Streams is one of Confluent's like big tools that they make. And so with Kafka, right, you've got all of these streams of data coming through. And Kafka Streams provides a really nice API that translates very well to Clojure to perform transformations on these streams as they're coming through. So you build what's called a topology. So like you've got the stream, it's got data in it. You might want to rekey it so you can look it up using a different ID per event. You might want to, you can do anything. You could map over the values and add them together, or change things, move things around, and then you can produce more streams from that. So you can branch and produce another set of event streams. Let's say you have success and failure cases. Those can branch out into separate streams from there.
Okay.
And you can do this all statelessly.
Huh.
Which is really exciting.
Does it manage like where stuff is sent to so that it can be run? Like how many nodes are processing each step in the process?
So that happens on a different level of the Kafka platform. The Streams API is just for processing these event streams as they come in. The actual consumer clusters and producer clusters are managed differently.
I see. Cool.
Yeah, it sounds like it's one of those things where, you know, you can imagine make a naive version of that stuff, but then if you really need it, you know, you might as well just like buy one of those things. And
we had an in-house naive version of it, actually. That was a lot of fun to migrate off of.
Yeah, it sounds really cool. It also makes me feel like I'm getting old. Like I have no interest in learning that stuff, but it's probably like you're gonna need to learn it if you have a job at a company at scale.
I mean, you need to pick what you invest in learning these days, right? You can't learn everything. Yeah.
I honestly think Kafka is one of the best tools we have right there. I think that Kafka is on the up. I think that Confluent is as well. Confluent provides some of the best tools for managing Kafka. Like I would be happy to be acquired by them if it were me. Like if it were me, like
that's a good company to be acquired by.
Yeah. They're doing really good and really interesting work. But Kafka is just really exciting. You know, there's a lot of talk about event sourcing and event processing. And there's been
Oops, lost you, Mia.
Speaking of streaming,
It'll be like nice thing. People say like, oh, is this a queue? I'm like, no, it's not a queue. I mean, it's not.
I think I need to read about this now.
Just spend like an hour or two and then.
Yeah, I think I'm on this trend.
Have you seen Turning the Database Inside Out? I forget. It's one of the Kafka guys. Let me see who did it. There's a really nice talk about the driving principles behind Kafka.
Yeah,
Turning the database inside out.
So one argument is like, let's say you have a SQL query, right? That scans basically rows in a database looking for things. Maybe you're looking for a pattern or something like that. And you can imagine what that is, because we've all done that. You do a query and you get like a rectangle out. And so some of these systems will just let you set up a query that just runs infinitely, right? And it's basically a streaming processing thing. And your query could then look for patterns in the data. So there's that argument. It's like, you're flipping the database inside out, or you're like turning it 90 degrees or something like that, so that the query is just running forever. And the table never really does get materialized. It's like streaming through the query.
Oh, that's neat. I mean, I could see a bunch of uses for this. Like you mentioned event sourcing, Mia, and I'm really into that. But then I'm also into like small software. Like I would love to have some way of doing this, like not at scale. Like I don't want the operational overhead of like Kafka instances, and I would rather be able to do it like locally on this little thing that I don't know. That it's one of the reasons why like I like Postgres. It's because I feel like it is stable, and I run it on my local machine, and I understand it. But then and running it is not hard either. But when you get up to these, I don't know, maybe they're not that new anymore. They seem new. I'm old, like I said. But like I start to get into this place where it's like, well, now I have to be running like 4 JVMs on my host, because Kafka's on the JVM, and it starts to get like, this is not small anymore, and it's way more, I don't know.
Yeah, although I swear I'm not a plant here, but Confluent does provide a set of tools that manage that locally pretty well.
Okay.
But no, it's only just like it's been exciting for a while, but I think it's only just now becoming really stable. Like the ecosystem is becoming very stable. Kafka's becoming very stable. Yeah, I'm excited to see more integrations between Clojure and Kafka. Clojure works really, really well for stream processing for a lot of reasons. And I would like to see where when someone thinks I want to make a stream processing app, they pick Clojure to do that.
One example of kind of problem.
Some pair of closures. Sorry.
Sorry. I was speaking because you froze up. I'm sorry.
Oh, geez.
Go ahead. Yeah.
Well, Clojure is really good for stream processing. Clojure is really good for running Kafka. I would like to see Clojure's killer app, maybe. Like Clojure, when people talk about like Clojure's Rails, like what does that look like? I'd really like to see Clojure and Kafka working together. Or people feeling like they want to use Clojure to build a Kafka app.
What does it need? What's missing?
An understanding of what to use it for. I think honestly, like a solid use case. Like everyone knows what a Rails app is for. I think that
everyone needs a website.
Yeah. So I think that's really like the strong, like what is the thing that is missing the most now that we're getting the tooling down, and now that it's becoming really stable, is a solid use case for it.
And the one use case for this streaming stuff, Eric, an example that, at least it's the way I understand it just through this example, is if you're trying to do a security thing where you're looking for people who are trying to hack in and like trying to log in over and over again. So you might have a stream of login events that are usually always successful. And in that stream, you have the identity of the person who's trying to log in and whether or not they succeeded or not. And your task is to find 3 logins that all occur within a 5-minute period, or 3 attempts that are all failed within a 5-minute period. And you want to do that at scale, Yeah. So it's a typical thing. Like, it's a pretty well-defined problem, and you could make a naive solution to it. And let these tools let you express this kind of thing as in a query language. You're like, find these 3 things all next to each other and temporally,
So I think that's a really great example, Mike, because like I have this dream of creating a Rails for Clojure, some kind of web framework. I'm thinking web frame, not just killer app. I think we need a web framework. And would Kafka be something to build it on top of? Because one of the things that Rails does that I think makes it very successful is you don't have to understand the database at first. Okay. I'm not saying like at some point you're going to have like self joins and like N+1 problems and stuff. But At first, you can just use active record. You're just like implementing some methods and everything works. And I would love to be able to do that in an event streaming way, where all you have to do as the programmer is like say, well, this event does this and this event does that. And they aggregate in this way. And then you can somehow just get that aggregate out of the database. Is that something that Kafka does?
It's more focused on the storage of the stream itself, right? Or the mechanics of letting you put some or build up a stream mechanically.
Yeah, it doesn't do what Postgres does. It wouldn't be for like, it would certainly be for different things than a Rails app is for.
Mm-hmm. Yeah.
It would be if you wanted to build tools that, like I could see it working really well for something that monitors customer actions on a site, for instance.
Right.
If you want to build an app that event sourcing is the central purpose of the app, I think that's really what it's for.
Right. Like, hey, they've looked at 10 things in the same category, but within 10 minutes, and it's been 2 minutes and they haven't looked at an 11th one. Maybe we should give them a coupon or something like that.
Mm-hmm. Mm-hmm.
Is that the kind of thing you could calculate in the stream? A 10-minute window.
Does Kafka even help you? I mean, Kafka's really good at storing those events themselves, right?
Yeah, and then you'd have to set up something else to process it. It must be possible because I'm thinking of ways to do it.
Yeah, I see. This is the thing where I just don't even know what this tool is for, and I would have to sit there and spend 6 months playing with it to really get it. Which is why I don't do that. I don't know how long it'll take. Do we have anything more to say about Kafka and Onyx? Congratulations, everybody at Onyx.
Yay, Michael.
Yeah.
And Lucas. That's awesome.
And it means more people are going to be using Clojure, even if they don't know it, right? That's cool.
That's true, yeah.
And if they're trying to grow this, they'll probably be hiring Clojure programmers too.
Mm-hmm.
Maybe. Okay.
Sorry.
Yeah. All right. So, sometimes we have these topics that one of us will put in, and then that person is not here.
Oh yeah. For this next one.
Ray put in this topic called imperative versus functional, and I don't know maybe we should save this for another time, because
maybe
I feel like if we start talking about it, he's going to be like, no, I listened to the episode and that's not what I meant.
You completely missed what I was getting at.
Exactly. So we're going to have to talk about it again anyway.
I just started learning Java, so I'm really, really happy to trash talk imperative programming all day.
Oh, okay. So,
don't let us stop you.
No, but oh God, it's so bad though. I just hate it.
Do you think it's necessarily so bad, or
it's just
that no one has done it well?
It upsets me aesthetically. I don't know. It feels like it's very, very easy to get to a level of complexity that is not only unnecessary but harmful.
Right, and you're not even talking about the problem. You're just like, I don't remember what this loop iterate. Like, when is this loop going to end? Can't figure it out.
But we should wait for Ray probably, because I'm sure that this is sounds like a Ray rant to me.
Yeah, like I think, I don't know. I was talking to him on Twitter because I was talking about how functional programming is not declarative. That I don't think that the term declarative really has much meaning except as a relative term, because you could say that like assembly language is more declarative than machine code because you don't have to calculate the jump offsets yourself. Like you can just declare what line you're going to jump to by putting a label on the line. And a for loop doesn't, like when you have a variable and you're going to, in assembly, you would have to choose what register you were going to store that variable in. Whereas in Java, you don't. So you're declaring, I want a variable, and you're not saying where it's going to be stored or anything like that. And so it's all relative. It's not, there's no absolute declarative, like, you know, computer, solve my problem. And
so you're just saying anytime you get away from how and you move up a little bit to the what, I'm declaring what I want.
Exactly.
And that even happens in assembly.
Yes.
Compared to machine
assembly,
language.
add a declarative use, right? I mean, it's the same thing like when Fortran was coming out, it was considered artificial intelligence because it was doing the work of people. People used to figure out how to compile a problem into machine code, and now this computer was doing it from some very high level description.
I know, you could write an arithmetic expression and it would compile that thing.
Right. And just you know, in the classic sense of like everything is artificial intelligence until it becomes like understood, and then it becomes parsing or compiling. And then people are always like saying, oh, what has artificial intelligence done for us? But like everything came out of artificial intelligence. It's just,
I mean, we're biased because we're Lispers. So
yes, exactly. That's true. We're very biased people. Know that. This is a Clojure show. But no, seriously, except for Fortran, what has anybody done for computing besides... Never, no,
awesome.
Don't quote me on that. Excel was very nice, and I don't think it came out of artificial intelligence.
Who was it? Someone had the really good hot take that Excel is the only truly functional language.
Whoa. What does that even mean? Because there's no like sending an email from...
Excel.
There's no side effects. Interesting.
That was one of my favorite functional programming hot takes, and I'm always trying to remember who said it, and I've never been able to find it.
It is the most popular programming language in the world. And number two, Visual Basic. So take that and, you know, do with it what you want.
Don't think about it.
And Clojure is way down on the list. All right. We're not jealous. Okay. So
save that for Ray.
Yeah, we'll save it.
Yeah. All right, John, we're gonna wait for Ray to get back so he can tell us what he meant by that Trello card.
I think also one of the problems is that these things are not that well defined. You know, like what does imperative mean? And like in Clojure, you can do imperative. Like you can just run one command after another, right? The function body, you know, executes in order.
Yeah.
I have a whole thing that I kind of, I don't know, I got hammered by Hacker News commenters on a blog post I did a couple years ago where I talked about how Clojure is very procedural. It's very imperative. Like its execution model is very imperative. And it's kind of cool how you can build a functional language on this thing where you just take the source code file and you execute one form at a time. And like, so the namespace doesn't exist. That form isn't declarative at all. It has what it does is it checks, does that namespace exist? If it doesn't, it creates it. Then it starts the imports and it does them one at a time in order. And then it does the, you know, first form, which is probably a defn, right? And it compiles it and stores it in the namespace. It's very imperative.
Yeah, it's mutating the environment as it goes down.
Exactly. And then
how dare you? That's blasphemous for you to say something.
I know. That's why I got so many Hacker News comments. But it's cool that like with that a language can bootstrap like that and become something that's much more expressive on top of this, imperative, execution model.
Yeah.
All right, it is 12:30, and we've got our REPL jump in viewership.
Right. Yeah.
So we're going to the REPL. I'm not going to make a lot of ceremony like I normally read something, because everyone's on YouTube. You're still here. We don't have to say anything. So let's go.
All right, I've clicked on the REPL, so hopefully it shows up in YouTube. Let's check.
Oh, I see it.
So, all right. It's the same REPL session we had from
Yep.
What was that? 4 weeks ago?
Who cares about the startup time? That's what I'm saying.
It's still running from 4 weeks ago. Yeah.
4 weeks. All right.
Wow.
Where's our problem statement here? All right. Write a function that rotates a list by k elements.
Ooh.
For example, here, I'm going to paste this example.
Okay.
So if we give it this thing, then we should be able to rotate it by 2 and get this thing. And look, I put this one in.
This is a good problem. Yeah.
Yeah. So, someone want to tackle this one?
Mia.
I am still trying to get. Yeah, I'm still trying to get in.
What are your thoughts, and what would we do to solve this one? Let's see.
An obvious one would be to do take and drop.
Yeah.
And then concat them back
together.
The opposite way.
That's, yeah, I like those, like the most direct, simplest form without worrying about efficiency.
Right.
Okay, so we could try that. Let's see. So, all right, I'll try typing this one in. I guess since Mia, you can't even type, can you?
Yeah, I've still got to send you my new SSH key.
Oh, okay. You're not getting in.
I'm not getting in. I forgot a permission denied.
Mike, you got so much security on this thing. You need like a key sharing system.
Yeah, I know. I'm afraid of the Russian hackers getting into my system. Let's see. All right, so. Oh, I forgot we have REPL readline going on here. REPL readline. See, write a function that rotates a list by k elements. Rotate's a pretty good name, right?
Yeah.
Let's see, and it's going to take a
collection, sure.
Maybe just a list, but
and a k.
What would you call it if it's just a list? X's, right?
Yeah, sure.
Collection could be a map. All right. So if I take, let's see. So it ends up so that the 3 shows up at the front of the answer. So in that case was k what? K was 2 maybe?
Yeah, 2.
So I want to drop. I'm going to drop first. Okay, that's my attempt at it.
Let's see.
Let's see.
You can copy paste those numbers up there just to test the example.
That one there. And I'm going to rotate this by 2.
3, 4, 5, 6, 1, 2. Okay.
Now let's try to break it. Put a number that's bigger than what it wants.
Sure.
Is that still working? I guess it's doing something. Huh?
Yeah.
Yeah, what do you want it to do in that case? I think it's an invalid program. Unless you wanted it to do some mod arithmetic or something. Anyway, the definition of the problem did not talk about that case, did it?
Yeah. Yeah. I tend to think that those kinds of cases where things are too big, like it should still work. Like, hey, you wrote like what if you did rotate 0? Like that should give you the same list back.
Yeah, that's like an identity.
Yeah.
Okay, so given that, my next step into efficiency world would be to try to do.
Oh.
I'm going to assume that's a vector.
Oh, you're assuming XS is a vector. Okay.
See, I want to.
So 0. Wait, no, K to the end, right?
Hello. Right. Just try this first, just to see what this is doing. Gives you like from that to the end.
Mm-hmm.
So this would go from 2 to the end, or whatever, K to the end.
Yep. You're doing a double into. Doesn't into take multiple sequences already?
I don't know. That'd be nice.
Did.
And then you wouldn't need the
Okay, let's talk about that and let's see.
Yeah, so into can have an into to from, and an into to and then transducer from.
Oh, so it needs.
So yeah.
So the other interesting thing is you don't need an empty vector. If subvec is already
right into that thing. Yeah.
Yeah. So you'll need one into.
And that basically. Mm-hmm.
Yeah.
Like this. I haven't thought through it.
That looks right. Yeah. That assumes that they're vectors.
Yes. And if they are, then the efficiency arguments would be, I guess, that you're not really doing much with that subvec operation other than whatever it does, right?
That's constant time.
Constant time. Okay. Yeah.
And so then the only thing you're doing is it's order K, whatever K is.
For that second into, or the length of the second subvec.
Yeah, exactly.
And it should be like, it should have that reducing goodness. Like the vector itself should be directly reducible. So it should not produce like a intermediate sequence to get that stuff into the first vector. For what that's worth, you know.
What happens if we give it 10?
Oh. No, Mia, no. Maybe that's better though. That's actually
could be.
I guess we could have a catch where if you get that exception, you return the list. If we wanted it to behave the way the other one behaved.
Oh, right. Yeah.
So why is it that if you do a take of too big of a number, you get the whole list, right? That, that's, to me, that makes sense, right?
Right. Okay.
It's like try to take 100 things out of this list. Well, there's only 4 in here, but I'll give those to you, right?
It doesn't throw, right? It just gives you.
It doesn't throw, right?
Yeah.
And so I don't know. It's probably wrong, right? Like if you were a dependently typed person, you'd be like, that shouldn't even compile. But to me, I just like that, right? I like that the behavior is not like, I guess, strict mathematically, but it seems much more forgiving and relaxed.
Yeah, that and like the nil punning and all that kind of forgiveness, I guess, makes it so that you can get away with stuff that is kind of loosey-goosey, but it works, right? But yeah, you could argue.
There's a lot of stuff that builds off of take as well.
Yeah.
So it's like take has to be pretty forgiving in that sense.
Right. And then, of course, the take and drop works on any collection, even though, some things don't quite make sense.
Okay, so I have another idea.
And then someone in the
Uh-oh.
Mia froze again?
Mia's gone. No,
Did she disappear? Okay, so let's try this one. So what I'm thinking here is just let cycle through them. And an
dropped out, Mia.
Oh yeah, and someone in the comments posted one using. We've got John Newman. Am I out again?
I hear you.
Okay. All right. Oh yeah. So yeah, John Newman in the comments just posted one.
It has a cycle.
Yeah, and it does take, count, call, drop, and cycle.
Does that work?
Okay, so
let's find out.
Lists?
Yeah, so his is basing it off of rotate. Let's take his. Where is it? Let me see. I don't have access to the comments. Which window did it go to?
Oh, I'll do it.
Okay, thank you.
Just copy pasting. We'll see if it works.
Okay, we're all so good at using software.
I know.
Take count of collection, drop in. Yeah, that's what I had in mind. Exactly that one there. Yeah, that looks good.
All right, so let's try it.
Yeah.
Have a here we go. Rotate. All right. That looks right. Now, does it work for an infinite list? That's what I want to know.
Well, if you try to cycle an infinite list,
you can cycle an infinite list, and you're only dropping from it, so that should work.
Okay.
And then you're taking off of that. Whereas I kind of feel like with the concat, like it wouldn't work. Is that right? We'll have to try.
Okay, interesting. So like if you use that rotate on an infinite list.
So let's just do range, right? Except
but take something from that, yeah.
Yeah.
That'd be wild.
Take 10 off of that.
Okay.
So it should just drop 2, right?
Hopefully.
Oh no.
Okay, so where's it stuck? Let's see. So
you can't.
Can you fundamentally cycle an infinite list? I agree that you can, but let's try that first.
Hold on. What do I need to do?
Yeah, there you go.
So all of a sudden I care about startup times. Okay. Cycle.
Okay. Range. And then take something from that and see if you can do it. I'm just curious.
Take.
John says you can't put the tail on.
Okay, so you can cycle an infinite range.
You can cycle an infinite range. You can drop n from it. Let's do that. Up 10.
But then take something from
and then take 10. Oh, the count of call, obviously. Oh, I can't believe we didn't see that. Count.
You can count an infinite range in ClojureScript. I'm just saying. Try it.
You do lots of things with the power of JavaScript on your side.
Yeah.
So if you have, well, you could try it. Let me show you. It's an oddity. It's not worth it.
Count range.
Yeah.
What?
Yeah,
that is not correct.
Do you want this?
That's all the numbers in the world. That's where the numbers end. We found it.
Yeah, that's a gigantic number, huh?
That's it.
How does it do that?
They don't get bigger.
Well, range itself is a funky beast, right?
Yeah. So it must know that it's infinite. Wait.
It doesn't actually like. It's just you're curious about how does it count range?
No, but it must know like, hey, I have no end because no one passed me an end, so therefore I must be infinite. So let me just do max int or whatever JavaScript it uses.
Yeah, I can't remember how it's. I think it's just. I think if I remember right, range is just an object that it builds or a def type, and that just happens to be the upper bound there in that case.
So wait a second. If you do range, what happens when you've overflown the long in Clojure? Like, does it start giving you big integers?
Oh,
Because then it might actually be finite, right? It could be like, oh, you're good to here, and then you'll crash, or I don't know. All right, that's digression. Okay, so you can't count. That's the problem with infinite. Is there a way to make this work infinitely? I think the first one should work infinitely, right? Our first definition, the take and drop.
Okay, let's see. The first one was the simplest, and maybe it does. Let's see. Okay.
Rotate range 10.
Okay.
Ready?
But then take something from that.
Yeah, you got to take otherwise.
It doesn't have print length on here.
Probably not. You could set that.
Okay. Gotta find it. Okay. Take 100. Ah, it worked.
See? That's nice.
That is nice. Is there a function that does the take and drop in one step?
Was the split is close to that, right?
Split?
Wait, is this actually? This isn't actually rotated though. This is
It
just
is because the first 10 got put after the infinite list.
Yeah, it's rotated.
I was never gonna see him again. Okay.
The doc function, so we can look at the doc for split. Is it not split? What's the name of that function? It starts with an S.
Sorry. Split at? Split at. Takes an N and a call. So split at.
It returns a vector of the take and drop. Yeah.
FN rotate. Okay. I'm going to call it rotate split so we can keep the old one. So it should be like A and B and split at K to S concat B A.
Okay.
Oops. Take 10. Okay. We could do range 10, and then we won't need the take, right? That's cool. I mean, that's a little more efficient, but it's the same order, right? It's the same big O.
Yeah, split at's not really doing much for you other than what is that function really good for? I mean, or what would be like some scenarios where that function would shine and really be good? I mean, it's like we are taking and dropping right now. Yeah. So this is an example where you might use such a function.
Right. And remember, this is the kind of function that I think was like when people were still using Common Lisp, like this kind of optimization was still very important. You know, it was like, oh, this one will get you 2 operations in one. You'll only have to traverse the list once. But I don't think that's so important anymore.
And if we tried to code golf using it, like you did a let, which is very clear. You could reverse and then concat. Yeah.
Yeah. Will that be
I mean,
better?
It would be like more complicated looking.
Reverse and then
maybe apply concat to that.
Yeah. Apply concat.
And it looks nice.
That's kind of fun.
mean, is that an argument for split at, I guess, in this case?
Well, I mean, if you turn it around and you did it like a thread, you could do like this.
Okay.
Split at KXS, reverse. Oh, we got to do a thing. Look, so we can do, look, we have this thing. Split it at K, reverse it, and then we're going to apply concat. I mean, that sounds nicer, but it also sounds very imperative. Right?
Speaking of that, have you seen Stuart Sierra's recent post about the threading operators?
I did, yeah.
Yeah. I keep reading that every week or so, trying to internalize it. So I think it's good advice.
What if we did one that, like, so I got this out of a list of, I think it was common Lisp problems.
Oh, okay.
And they don't have the same habit of using, like, you know, I don't know, as so many functional things. Like, I would assume that they were like, oh, this will be a cool recursive problem to try to do.
Okay. Yeah.
How could we do that so that, you know, you're counting how many things you're taking off, and then you're ready at that point to.
Oh, if you tried to do a recursive solution to this.
Yeah. Let's do that.
Also, Bobby Towers gave us a Juxt solution.
Oh, really?
Oh, Bobby,
we have to use Juxt. Yeah.
That's
mandatory
right now.
That's a moral imperative. We must use Juxt.
We must use Juxt.
All right, here it is. Okay, let's read it. Apply. Oh, I love it. Apply concat Juxt mod and count call. Oh,
I'm so happy to see Juxt. Yeah.
Wow. All right, let's see if we can decipher this, because this is not coming to me. So it looks like you're calling Juxt with the same number twice, this mod and count call. So you're kind of drop with that number, take with that number, and then applying the concat to the Juxt. Oh, wow.
Is Juxt drop take the same thing as split at? Is it pretty much the same function? Or?
Yeah,
actually, let's take a look at that.
Yeah, I think it is.
Oh, we probably don't have sort. Here's our little thing.
Yeah, just
split at returns a vector of take and call, drop and call. That is the official docs for split at.
Oh, we can do that ourselves. Like,
that's not... Oh, Juxt would. Yeah, if you did Juxt in the other way, it would be like that, right?
Right. Well, Juxt.
You'd have to partially apply some stuff to get the end partially applied. Okay. Anyway.
All right. Let's try it. Let's run it.
I'll do it. Rotate. Right. Rotate. Where's our range? This one won't work with infinite because it's got the count.
Count in there. Yeah.
Rotate to. There we go. Uh-oh.
Oh.
Well, let's look at it.
It's not supported on.
I don't want to.
Got to reverse the argument order that you passed.
Oh, that's what happened. Yeah.
Oh, I see.
Bruce. All right.
There we go. I get a supercut of us saying Bruce every time.
Every time we hit return in the middle of a form.
Bruce. I think it's cool how we're all like friends and first name basis.
Yeah.
Mr. Howman, the creator of
Sir Howman
Rebel Readline. Yes, this is cool. So this is one of those things in Juxt that I almost never use, and it surprises me every time I see that it can take two arguments. Right? I never use that.
Yeah, that is weird about it. That stuff on the higher arities. Yeah.
We have actually a really nice use of Juxt like non-ironically in our code to pull 3 keywords out, like to compare 3 keywords
Yeah,
from a map.
Ironically type it in.
Yeah, no, I did not. Someone else wrote
Can
it.
you do it now so we can see it?
Let me get it.
Like if you want to sort a list of maps and you want to make a comparator right there on the.
You know what's cool is I can just search the entire code base for Juxt because it's only
like 3 times that it's used.
Oh God! Wow, we have a lot of these.
So wait, it's for doing what? It's for comparing 3 things?
If you want to make a comparator for maps and you want to like sort by this column first and then by that column.
Oh, yeah.
Or if you want to add them together.
Yeah. But like, yeah, if you're doing a sort by, you can do like sort by Juxt. Well, you don't even need the thing.
Yeah, just
Juxt.
Yes.
Yeah, right. And so you
colon
do
A, colon B.
Yes. 2.
Yeah, that is nice.
Like that. And then, whatever.
And list of maps. Yeah. That's like
that's nice.
That pattern needs a name. It's like the Juxt idiom for sorting.
And I like how, see, this is one of those things where like my type sensibilities say, oh, those should be all keywords, except it's awesome because you don't need to do that. You can do Juxt first, right? And then have other stuff in there. Like, I love that.
This is one of our Juxt uses that we have.
Wait, let me see. Reduce. I'm gonna paste it in here.
Ooh, what is that?
That was supposed to be a C, not a dash C. I had to anonymize our keyword names because
Yeah. They contain your passwords.
In plain text. No, they don't. Please don't.
AWS keys. All right. So
you
ABC.
So you pluck those 3 things out of this.
Yep, and they are.
Is V actually going to be a map in that case?
So yeah, V is a map, and those are all integers.
And then you add them up with reduce plus 0.
Yep.
Interesting. I wonder what it would look like to simply.
It's a pain in the ass.
Do it directly.
It's
the normal
easy,
solution?
but it's longer. Makes the line really long.
Right. So you do plus A V B V B V C V.
Yeah.
Yeah.
That's pretty clear, but it doesn't use Juxt.
No, it's not as cool. This is much cooler.
If you can use Juxt, you must.
I'm actually like really surprised by how many uses of it I found. I'm going to go through and audit all the internal Juxt uses.
You could probably find some cool ones. You should post them on Twitter, I'm sure.
I'm going to get blame and see if like the same person's responsible for all of them.
Someone should make a Twitter account that is a bot, that anytime someone uses Juxt on Twitter, any open source project, it just posts it. Like,
that's good. We call it just Juxt.
Awesome. Someone do it. Do it.
I gotta go. It's 1.
All right. Bye, Mia.
Bye, everyone.
I guess we are pretty much done, huh?
Yeah. All right. Bye, everyone.
Once we got Juxt in our system. Oh, man.
All right. I was just going to say you can always use Juxt to make vectors, right? Like that little example there.
Oh.
like never actually make a vector directly. Just use Juxt, right?
Juxt is a constructor.
It's a universal vector constructor that takes functions and makes a vector for you.
So what did those things get called with? Because you didn't have an argument.
I applied it to nothing at the very end here. So yeah, I was wondering if that would even work.
Nil?
Like if you would put X there, it would.
Well, you
nil there.
Nil, but yeah.
So I was just assuming you wouldn't need anything there. That's interesting that both of them actually work.
Yeah.
Without one of them throwing a nerdy error.
I mean, maybe it just got called with nothing. Like, because constantly works with nothing.
Yeah, that's why I did this way. I just wanted nothing. Yeah.
Yeah.
And it applies constantly 1 to nothing.
No arguments. Yeah.
Yeah. Like that. I don't know. Anyway, silliness.
Very cool. Do we have anything more to talk about? Were we working on a solution? I feel like we were halfway through one where we got sidetracked by.
We were talking about doing a recursive version of that.
Oh,
rotate.
Yes.
Like if you wanted to do it the old school.
Old school way.
Yeah. The
Rotate.
McCarthy way. Yeah.
So let's say collection and K.
Mm-hmm.
Hopefully
And you're just going to assume collection is like a list, an old school, a cons list, right?
Right.
Okay. Yeah, this is interesting. So
okay. So,
and the strategy is like you would think, like, how do you get K elements out? Well, do you like build up the first K and stash it to the side?
Yeah. So you start with an accumulator, and then you have K start at K, and you go to 0. Right. So like.
Okay. All right.
So if 0 K, then you're just gonna concat. Oh wait, but you need to have the rest of the list. You're gonna have call like that.
Okay. Yeah.
Concat, call, and the accumulator. Okay. And I mean, we're just implementing take, but then we're putting call. Look at the concat at the end instead of.
Mm-hmm.
Otherwise, we're gonna recur, and we're going to. I guess we need another case when collection is empty. If we finish that, but we'll deal with that in a minute. So we're going to conj on the accumulator, the first of the collection. We're going to decrement K, and then we're going to do the rest of the collection.
Okay.
Rotate recur 1, 2, 3, 4 by 2. Oh, it worked.
It worked.
If you do 20, it's gonna like nils. Yeah, because we're doing first on it.
Okay. Yeah.
So what we would need to do is have another case.
Okay.
So if we have empty call, we'll just return the accumulator.
And then put your little else down there, right in front of the recur.
Yeah. Oops. Or have matching. Oh, too many.
Too many? Still too many. Okay.
So now, yeah. Bruce, how do I get up to the top? Okay.
Yeah.
Okay.
That's nice though.
It's nice. I mean, obviously, it's not as good as
in terms of performance.
Order.
Yeah.
Well, no, just I wonder if you could do a performant one. So this is something about concat. I was actually looking at the code for concat, how it's implemented.
Yeah.
Because it actually isn't as lazy as I thought it was.
Okay.
It's
been maligned. People are afraid of it now, right?
Well, it's right because it's constant time.
Mm-hmm.
And what it does is it actually walks, unless it's a chunked sequence. If it's a chunk sequence, it walks the chunks and it just reuses the chunks.
Okay.
But if it's meaning it doesn't go down to the individual element level, it stays at the chunk level. But if it's not chunked, it actually takes one and it recursively calls it it does what you would do like naively to build a concated list, a new list with the first thing, and then you recursively concat the rest of the list with the second list, and I thought just like how range is now its own type, its own class, its own object, and it's not actually a function that's like lazily building up a seek. I thought concat would be its own object that knew I have a left side and a right side, and when my left side is done, I can just return the right side, right?
Okay.
And so that way it would be constant time to concat something, and until someone like walked down it, it would, you know, it would maintain the yeah, that's what I thought it would be. Just because, like, why not, right? Make a constant concat. All right.
Yeah, I feel like I need to read concat again because I would accuse myself of doing what I said, which is being afraid of using concat when there's probably scenarios where it's perfectly fine.
Why would you be afraid? Because it's
there was like some post, maybe a Stuart Sierra post about Stack Overflows that could occur if you use concat in certain lazy scenarios, and it's been so long since I've read that post, but there's like some good reasons to avoid using concat. But I in my simplifying mind have probably avoided it.
I don't think. I mean, it is lazy, right? So like, it has a lazy seek wrapped around it. So
yeah,
like it's not going to blow the stack. But at the same time, I feel like it could be smarter by special casing. I guess that's what I'm thinking. Like the code for it would be way easier to, but it would be a new type, you know, and that has a huge effect on the JIT and everything, as we've seen in other cases where people try to special case things. Yeah. Anyway.
Right.
Well, folks, if you want to subscribe, please do. If you subscribe, you'll get notified when we're going live. And so I think that that's like reason in itself, just to like never miss the live ones, because we really do enjoy the chat that goes on, and I'm sure you do too. So yeah, hit that subscribe button, and we'll see you next time.
Adios.
Bye.